Hello, I want to tell you a little bit about how to complete our Getting Buggy with It activity. So at this point, you should have already collected your data from the Buggy, and you should be now working with this Getting Buggy with It file within Notability. So to be able to show you a little bit more, I'm going to pop up my iPad so you can see a little bit more about what's happening here. All right, so you should be currently in Notability. You have data written down, and I have some example data here. It just happens to be data involving just some random numbers, not at all reflective of what you guys would have seen on your buggies and with your buggies. You can notice that on this graph, I have my independent variable as time, and I labeled my units as seconds. So this is the variable I was controlling, and then I measured the position from that. So, and I'm actually going to change the numbers just a little bit to make it a little bit more in line with what you probably would have seen. Numbers that are maybe not quite as perfect, but close. So if you look at these numbers, what you'll notice here is that they're really, really close to increasing at about 2, in this case, meters. So I have position as my dependent. This should actually say dependent at increasing at 2 meters for every 1 second of time. So as a result, this would be a linear model or a linear increase. In other words, a constant rate of increase. So what we're going to want to do now is graph this. So as we're going down here, we're going to be looking at the Desmos app, and that Desmos app is going to be allowing us to graph our data and then come up with a best fit line. So if you've not already done so, download the Desmos app to your iPad. Pause this video if you've not done that. Then what you're going to do is you're going to click on that Desmos app, and you're going to be able to open up within Desmos a program that you could then link over, and over here in the upper right hand corner, you're going to want to log in and log into your student Gmail account, so into your School District of Waukesha account. And at that point, you're going to see that there is an untitled graph. So I'm going to label this, click on that untitled graph, and label it as Buggy Lab Algebra. And now, well, the first thing I'm going to want to do is label my axes. So right now, you can notice that there's no axis label. So as far as X and Y. So I'm going to click on this little gear over here. And on the x-axis, that's going to be my independent variable. And my independent variable was time. And I always want to label my units on there too. So time in seconds on the x-axis, and position, and according to my data table, we had meters on the y-axis. So you'll notice that the graph will then represent the appropriate units. And now what we're going to want to do is increase. So you're going to click on the little plus button or insert a data table. So plus button table. Notice how it says on the x-axis, x1 is going to be what we would have as our independent variable. So this would be our time data. So I'm going to have my time data entered in here. 0, 1, 2, 3 seconds. And then I want to type in the corresponding y data. So I can actually look back over here and look at what I had for my y data. So this would be my y information, and this would be my x information. So the independent variable is your x, and the dependent variable is your y. So 0, 1.9, 4.1, and 6. And you'll notice that it automatically goes and inserts that data onto the graph. So it's made those points. So now what we want to do, now that we look at this, we can see it looks really linear. So now we want to develop a best fit equation for this. So you can use Desmos for that too. Once again, click on that plus button, and now click on expression. So now we want to type in that we think this is going to be a linear fit. So we want to tell Desmos that we want to come up with a linear equation. And that linear equation is going to be y equals mx plus b. So we'll click on y. And now instead of the equal sign, we actually use, this is kind of a little tricky. You're going to want to use this little tilde down here. It looks like a line that's kind of just a little wavy. So one wavy little like line segment there. But now I made one mistake. Your wide value is actually not just y, it's actually going to be y1. So I'm going to type in y1. Then I'm going to put that little tilde little sign in there. Then I'm going to keep going with y equals mx. But now notice that my x actually isn't just an x, it's actually supposed to be an x1. So I'm going to go and put an x1 in there, plus b. Okay, so this is going to be the equation as of right now, the information I have. You notice that this orange line is creating a best fit. You'll notice the little green dots are a little bit off that line as part of the scatter plot. But when you create this best fit line, what the actual Desmos calls a regression fit, but it's really just a best fit line. And you'll notice that up here it gives you your slope, your m value, and your b, which is your y-intercept. This is the important part that we want to write down. So 2.02 and negative 0.03. So I'm going to go back over to my sheet here, and I'm going to have a screenshot that I'm going to insert here. This is where you're going to put your screenshot. And then I'm going to type in and write in my equation. My slope was 2.02. And my b value, my y-intercept, was negative 0.03, I believe. Let me double check. Yeah. So now I want to go and write this into a slope-intercept form. So y equals mx plus b, except now I'm using a slope. So y is equal to a slope of 2.02, which is what I got over here, times x plus negative 0.03. So this is going to be my slope-intercept form. Now, I'm going to want to keep doing this. So you're going to do the same thing, but with your data. Now, what I'm going to do for this next part, down for this whole idea of the physics equation, is for the physics equation, we just want to substitute in the physics variables. So if I look back at my graph, for me, on my x-axis, I had time. So instead of an x, wherever I see an x, I'm going to put in the time variable. Now, if I look over at my y-axis, instead of my y variable, I actually am using position. So I'm going to go over here and I'm going to put in, instead of my y, I'm going to plug in the p variable for position. Now, I know my slope was 2.02 times t, and my y-intercept was negative 0.03. So this would then be the physics equation that I'm working with. Now you're going to finish up the rest of this lab, do some analysis on what you think the slope represents, what you think the y-intercept represents. You're going to convert it into standard form, and you're going to go through and start to make some predictions and a self-assessment. From there, you're going to use this as your artifact that you're going to want to submit to me when you go back over into your portfolio. All right, hope this helps.